So, in n times my m game, we've got here, our offensive player has 3 strategies to use. We'll say he uses probability P1 for strategy X1, probability P2 for strategy X2, and probability P3 for strategy X3. So, from X's point of view, if Y plays strategy Y1 down here, X can expect a gain of 2 with probability P1, a gain of 5 with probability P2, and a gain of 1 with probability P3. If Y plays Y2, we get 4, 2, and 6 with their probabilities. We also now know as well that P1 plus P2 plus P3 equals 1, because you only play those 3 strategies, so those 3 probabilities have to add up to 1. V is going to be the value of the game, and X is going to try and maximise V. That's what player X wants to do. We call P the payoff, and the payoff equals the value of the game. So if P equals V, we also get P minus V must equal 0. Now this is something that you're coming into in a minute with the simplex. You can write this as a linear program. We are trying to maximise V, the value of the game, subject to these constraints. The value of the game has to be less than that. As we said before, we did that shading. It's the underneath shows like the feasible region. And the value of the game has to be less than that. And we know as well as another constraint that the probabilities add up to 1. Now what I'll do is show you how that goes into a simplex tableau, and sort of we'll do it sort of line by line as we go through.
What do you say when they say how do you show something like this?
For this tableau, columns, this is at least the way your textbook does it, has a P and a V, then it has the probabilities, then it has any slack variables you need. So we'll have an R and an S and a T, and we'll have a value. Right, first off, line 1, I'll call it line 1 over here, comes from here. Okay? That P minus 1V has a value of 0. And everything else on that row are zeros. This is how your book takes it through. The second line I'm going to do here is going to come from this equality constraint here. In this equality constraint, I have 1p1 plus 1p2 plus 1p3 equals 1. Except your book as well adds in a slack variable there as well for that one. They treat it as a less than or equal to. So they actually have the P, the P, the P, and a slack variable. Everything else on that row they have as zeros. The third row looks at the constraint here. So my third row is coming from here, which is V will be 1. Now if you move these across to the other side of the equation, it'll be a minus 2, a minus 5, and a minus 1. I need a slack variable. The value will be 0, and every other entry on that row will be 0. The fourth row in my tableau will come from the other P constraint. So, again, I've got a V. These go across to the other side to become negatives for -2, -6. I need to put a slack in, so I use my third slack variable. Have a value of 0, and every other entry is 0. So that is how they put that together. And then you've got to ask yourself, okay, well, where will you pivot? If you were going to do this, where would you pivot? Which column would you pivot on? Yeah, you're always on the most negative in that row, so you'll pivot on there. So you can find your pivotal column. Then you need to find your pivotal row as well. And if you work out your theta values, they're actually all 0. Okay? So this is a case where it doesn't actually matter which one you do next. And what your book tends to do is always pivot on one of these two down here, and it doesn't really matter. And they would probably say, if they were asking you to do it, and then choose that one or that one to be your pivot. And then you would carry on doing it. What happens, and this is actually going through in the book, 4 tableaus later for this one, 4 tableaus later, you get p-value, so that's the p, that's the payoff value, which equals the value of the game. You get strategy 1 isn't used at all, and strategy 2 and strategy 3 are the ones that X should use. So as we would expect, one of those will be 0, so only 2 of these will be used. Okay with that one?
Yeah.